Connecting multiple tanks. In this diagram, I have got tanks set up in parallel with this connecting piping where the, what I'm calling this outlet port in between tanks, and the final tank has a pump and overflow. In this configuration, yeah, the water level in all tanks will be the same. And the last tank in line is the only one that has the overflow outlet. One thing that I know about this particular configuration is that you really don't want to set them up at different elevations, those tanks. That's going to cause issues.
Absolutely, Michelle. And, a Greek philosopher called Archimedes actually discovered that the elevation at the top water level will always be the same. Well, its standing position will be the same, its point of equilibrium. That there are a few issues to think about. The first thing is, Michelle, to pick up on your point, the water level, the elevation of the standing water level in the tanks will end up at the same value, not the depth. So if
Yes.
in your diagram, if each one of these tanks is sitting at a different base level, it will attempt to make the water level, the water elevation, not the water depth, the same throughout all of it. And that's a key design thing to think about, which you were referring to, I think, Michelle.
Yeah, that'll reduce your capacity of the tank at the highest elevation, because it'll only fill to the same elevation as the tank at the lowest elevation, right?
That's right. And in fact, if the difference is elevation is too great, what you'll end up having is all the water in the bottom tank and none in the top tank. So you need to be careful about the Archimedes principle, it's called. However, that could be useful if you've got a problem of managing stormwater flows, but you need to think carefully about this type of design if your elevation of the base of the tanks is different. There's another point there, though, Michelle. Inlet is at one end, and the pump and the overflow is at the other end. So obviously the behaviour of this set of tanks in series and how quickly it reaches a single water level elevation depends on the capacity of the plumbing. So a lot of water pours in from the roof, but if the join between the tanks is quite small, the flow rate will be tiny, so the ability of the tanks to equalise will take some time. It won't happen instantaneously. So the water levels, the water elevations in those tanks won't always be the same unless the connection between the tanks is reasonably large.
Reasonably large. Okay. Yeah. Yeah. The other possible configuration is, this idea in series where the tanks are set up connected via the overflow piping, right? And this particular drawing has quiet inlets, which I wouldn't do now, having been through this course. But the idea that this first one will fill and then cascade down into this one, and then this one fills and then cascades into the third one. So it seems to me, in principle, this one would be possibly better for longer settling times and might deliver higher quality water than a system in parallel.
Interesting design concept, Michelle. I think about rainwater harvesting systems. The more you're involved in the industry, the more really interesting and innovative and different design configurations you come across. The principles we're talking about in this course will apply to a whole range of different design processes. In this case, pumping out of all of the tanks is probably okay, Michelle. I don't know if you'd need to, but it would actually vary where you take the water from, or the pump will try and take the water from each tank at once. Hydraulics 101. Actually, that's quite a complex design. In theory, though, as you go from tank 1 through to 3, the water quality in those storages should be better.
Mm-hmm.
So tank 3
Mm-hmm.
should have far better quality than tank 1.
Mm-hmm.
Um,
But I think it is a lot of extra piping to be able to set up this configuration, because even though the overflow is here, you end up with operational constraints in that when this tank is empty, if this pump is connected to this tank, you have no way to access the water to tank number two unless you also have this almost bypass pipe so that you can change which pump you're drawing water from. So really, I mean, the in theory it should have better water quality. I don't know if this justified for the added configuration complexity.
and in this case, I would prefer your first diagram, Michelle,
Mm-hmm.
which would also have better water quality where the pump is, by the way, because of the natural processes of getting to one storage to another, and
Mm-hmm.
using good old Archimedes principle here of just having
Mm-hmm.
the pipes connected down the bottom. Um, and in fact,
Right.
it I've seen this done on a rural area where an architect designed this area. It was off grid, and it was a large visitor centre, and it was also, people stayed there. It was also used as a convention centre, and
Mm-hmm.
people went there because it was as a in our beautiful bush, and it was architecturally designed. It only ran off rainwater, and the architect, who didn't know anything about rainwater harvesting and water quality, kept saying to me, "I've got all these tanks in series, and the water looks really crap in the one I keep looking in, which is the one close to the roof." Um, that's because he had no filters or screens or anything in that, so which we're not going to do. But the bottom tank, like almost exactly the last tank, almost exactly that configuration you're talking about now, except he had about 10 of them. All the health testing out of his tank always showed the water was very high quality, and that's because of that in series arrangement there.
Mm-hmm. Okay. Well, sounds good. I think that the conclusion coming out of that is that this configuration where the tanks are connected downstream of this, outflow port where the pump would otherwise be just on a single one tank is the ideal configuration for connecting multiple tanks. And don't forget, of course, same as what we talked about with pumps, flex joints or some flexible piping is a really good idea in between tanks, as well as, of course, all these tanks are going to have their own air vent as well as isolation valves. Really a good idea.
I think it's a good design if you've got
Mm-hmm.
room for that many tanks and a budget.
Yeah. All right. Thank you.